In this example, we're going to look at writing a function M file that's designed to work with vectors. So our problem here is to write a function M file that accepts a 2-element vector as an input and returns the following outputs. One, we want a scalar that counts how many prime numbers there are in the interval between the two numbers that are input. And second, we want a column vector containing all those prime numbers that lie between those two numbers. So let's look at this function. I called it primefinder.m, and you can download it from the folder where this video lies, and I would encourage you to do so. Make sure you understand how it's working. So we have our function command defining our two outputs. We have the scalar count and what will be our vector of prime numbers that I called p interval. And then our input is one variable, but this will be a vector with two numbers. Recall, it's a vector with two numbers. Then we have our help comments. Then what we're going to do, since we don't necessarily know which order the numbers in the input interval are in, we will explicitly get the minimum and the maximum numbers in the interval for our strategy to solve this problem. And then what I did is I'm using the primes function to return all numbers, returns all prime numbers up to the input. So this function will return all prime numbers up to the value p max and assign those to the variable all primes. Then what I need to do is get rid of the elements that are below p min. So in order to do that, I'm going to use this relational operator to say find all of the prime numbers, all the elements in all primes that are greater than or equal to p min. Take all of those elements that are in the variable all primes and assign them to p interval. So we assign those to p interval, and then primes returned a row vector. So we have one last little thing to do here. We need to convert, so p interval will also be a row vector, and we want a column vector. So we'll use the apostrophe to transpose and create a column vector. There's our output p interval. So we've got the first one. And then we need to count how many prime numbers there are, and that's done by simply counting the number of elements in p interval. So we'll use the length built-in function that we talked about that simply counts the number of elements in the variable p interval. So here's an example, and I'd encourage you to download this function and run it in MATLAB and try out your own examples. But here we tried to find all of the prime numbers between 10 and 39. We see there's 8 primes, and there they are: 11, 13, 17, 19, 23, 29, 31, and 37. So download it and try it out. And again, the key is you want to make sure you understand how is this function working. We're getting into more sophisticated programming now. We have vectors, we have a user-defined function, we're using a variety of MATLAB's built-in functions. You want to make sure you understand and are comfortable with how this is all working together to solve this problem.